Okay, now we are going to do a little bit more with partial fractions. This time, we are going to look at how you handle when there is a repeated linear factor in the denominator. The steps are going to be very similar. You just have to remember a couple of little things. The key here is that every power has a part. So when we go to break things apart, we have to keep that into consideration. So our problem we're starting with is 3x over x minus 3 squared. This has a repeated linear factor because you have x minus 3 and x minus 3. So when we write this, we're going to have 3x, and then if we wanted to think about what it would actually look like factored, we'd have x minus 3 and x minus 3. Or we could leave it as x minus 3 squared, okay? The key when we go to break it apart is that we are going to have every power is going to have a part. So when we go to write it, we're going to have 3x, and I'm going to keep it as x minus 3 squared, okay? Just keeping in mind those two things are equivalent. I just have them put together. So every power, I have two x minus 3's. So every power, x minus 3 to the first power, is going to be one part, and x minus 3 to the second power is going to be my other part. And then I just have to put my a and b in the top. Okay, so if we're going to find a common denominator, okay, just like we did, we need to have an x minus 3 and an x minus 3. Well, looking here, this factor is missing, or excuse me, this term is missing an x minus 3, which means we need to multiply the top and the bottom here by x minus 3 so that they all have the same denominator. So we would have 3x over x minus 3 squared equals a times x minus 3 over x minus 3 times x minus 3, which is x minus 3 squared, plus b, and we already had x minus 3 squared in there, so we're fine. So now we have it broken apart. We have common denominator here, so now we are just exactly like before. We are just looking at our numerator, okay? So let's keep moving along on our steps here. We're going to have 3x equals a times x minus 3 plus b. Okay, well, let's, just like before, we're going to choose a value. I'm going to eliminate a. So I'm going to choose x equals 3, because that would, 3 minus 3 is 0, which would eliminate that term there. So we're going to have 3 times 3 equals a times 0, so that's going to cancel, plus b. There's no x on b or anything like that, so we don't have to put a 3 with it, which means 3 times 3 is 9. My a is canceled out, so my b equals 9. So let's go back here, take our equation, 3x equals a times x minus 3 plus b, which is 9. And this time, we can choose any value that we want. We've already used x equals 3, so we can use whatever value we want. I'm going to choose to use x equals 4. Again, it doesn't matter at this step what value you choose. You will always get the same thing as me. So I'd have 3 times 4. A times 4 minus 3 is 1. That's why I chose 4, is because it was a nice 1 as a coefficient, plus 9. So then I have 12 equals a plus 9. So my a value is going to equal 3. Again, if you chose a different value for x, you would still get that a equals 3. All right, and our last step is to go ahead and take that partial fraction and put our a and b values in there. So we're going to have 3x over x minus 3 squared. And instead of a, we are going to put 3. So we're going to have 3 over x minus 3. That was our first factor. Plus 9 over x minus 3 squared. Because remember, when we are coming down to this step, we are not including these reds that we used to find common denominators. All right, let's take a look at another example here. we have 2x, zoom in here, 2x minus 3 over x minus 1 squared. So we've got 2x minus 3, x minus 1 squared. It's already factored. We're just going to leave it as 2x minus 3 over x minus 1 squared. When we factor it and break it apart, we have a squared. So we're going to have an x minus 1 and an x minus 1 squared. So we're going to keep the 2x minus 3 over x minus 1 squared. Our denominators, every power has a part. So we are going to have x minus 1 to the first power. And we are going to have x minus 1 to the second power. We're going to put a on top, and then we're going to put b on top. When we have to find common denominators, again, we need to multiply that first term there. All right, I'm going to use a different color. I'm going to make my pen a little bit thicker. And we're missing an x minus 1 here, because we have to have x minus 1 and x minus 1, which leaves us with 2x minus 3 over x minus 1 squared equals a times x minus 1 over x minus 1 squared plus b over x minus 1 squared. Now we have it into our parts, and our denominators are the same, which means we can just solve our numerator. So let's take our numerator to, oops, I don't want that because I wanted it to be a pen, not. So we are going to have 2x minus 3 equals a times x minus 1 plus b. Let's choose a value of x. In this case, let's get rid of our a here. So we're going to use x equals 1 because 1 minus 1 equals 0. So we're going to have 2 times 1 minus 3 equals a times 1 minus 1, which is 0, so that's going to cancel, plus b, and 2 times 1 is 2, minus 3 is negative 1, equals b. So we should get that b equals negative 1. Let's take this equation here, and we're going to rewrite it with b in it. So we're going to have 2x minus 3 equals a times x minus 1 plus negative 1, or we could have just put minus 1, same thing. Need that 1 there. Now I need to pick another value of x. Okay, it doesn't really matter what. I'm going to choose x equals 2. And the reason I chose x equals 2, you'll see here in just a second, is because if I put in 2, I get 2 times 2 minus 3 equals a. When I take 2 minus 1, that gives me 1, which is nice because then I have a coefficient of a that's just 1. That makes my life a little easier. So 2 times 2 is 4. 4 minus 3 is 1 equals 1a minus 1. So then I just need to add 1 to both sides, and I get that a equals 2. So now I have both of my values for a and b. So I come back up here to step 2, and keeping in mind we are not including this red stuff here that we use to find our common denominators. In our final answer, we're going to have 2x minus 3 over x minus 1 squared equals, instead of a, we are putting 2 over x minus 1 plus negative 1 over x minus 1 squared. Okay, in our final step, we do not have common denominators. We had to find common denominators to find a and b, but in our final answer, we do not have common denominators. All right, last one. This one has no steps for us, so let's take a look here and see what we can do. This one's going to have a little bit more involved to it because, as you can see, it looks a little bit more difficult than the other ones. So step 1, let's factor that denominator. I'm going to take out an x. That leaves me x squared minus 2x plus 1. And then this I can factor again. So I'd have x, and then it would be x squared minus 2x minus 1 would be x minus 1 times x minus 1. So when I factor this denominator following these steps, I'm going to keep 3x squared minus x plus 5. Remember, we do not factor the numerator. We only factor the denominator. I'm going to have x times x minus 1 squared. Okay, so that means we're going to have 3 parts to our fraction this time, because we're going to have an x. We're going to have every power has a part, so then we're going to have an x. We're going to have an x minus 1, and we're going to have an x minus 1 squared. So if we break that apart, right, our first factor we have is x. That x minus 1 squared, just like before, we have to have our x minus 1 to the first power. We also have to have our x minus 1 to the second power. And then now we have a, b, and now we are also introducing c. So as you can see, this one's going to get a little bit more difficult. So our next step here, we need common denominators. Well, I have an x and an x minus 1 squared. Well, my first term here, I'm missing an x minus 1 squared. Okay, so I multiply the top and the bottom. Second one, I'm missing an x, but I'm also missing an x minus 1, because remember I have to have x minus 1 and x minus 1. And on my last one here, all I'm missing is an x. So looking at now, I've got my denominators are all the same. I can just focus on my numerator. Okay, so my numerator is 3x squared minus x plus 5. Again, we do not care to factor that. We're going to have a times x minus 1 squared plus bx times x minus 1 plus cx. All right, now we're picking our values for x. Well, let's get rid of this one, because if I use x equals 1, that's not just going to get rid of a, that's also going to get rid of b. So let's use x equals 1. So I had to delete a little bit there, so we are going to have 3 times, oops, let me use black here, 1 squared minus 1 plus 5 equals a times 1 minus 1 is 0, plus b times 1 minus 1, which is 0, plus c times 1, which is just c. Okay, so then we're going to have 3 minus 1 plus 5 equals 7. And we have a times 0, b times 0. Those are both going to cancel, so we're just left with c on this side. So c equals 7. So then we're going to take this red equation here, and we're going to put in 7 for c. So we're going to have 3x squared minus x plus 5 equals a times x minus 1 squared plus bx times x minus 1 plus cx, except instead of c, we are going to put 7. Okay, so now I need to pick another value of x, and I'm going to choose x equals 0, because if I put that in here, b times 0 is going to be 0, so that's going to get rid of this term here in the middle. So we're going to have 3 times 0 squared minus 0 plus 5, that should be a 0, minus 0 plus 5 equals a times negative 1 squared, because 0 minus 1 is negative 1, plus b times 0 times negative 1 plus 7 times 0. So just a reminder here, I forgot to write this, that we're doing when x equals 0. So we'd have 0 minus 0 plus 5 equals 5. And then negative 1 squared is negative 1 times negative 1, which is positive 1a. This is going to cancel to be 0 plus 0, because 7 times 0 is 0. So we get a equals 5. All right, so now we're going to go back up to this equation here. And we're going to put a is 7, and, or excuse me, a is 5, I'm sorry, and c equals 7. So we're going to have 3x squared minus x plus 5 equals, instead of a, we're going to put 5 times x minus 1 squared plus b times x minus 1 plus c times x, which is 7x. All right, all we have left now is to find b, so let's think what value we want to use for b. Well, I'm going to use x equals 2. And why did I choose 2? Because if I look right here with my b term, if I say 2 minus 1, that gives me a 1. That's why I picked it. So we're going to have 3 times 2 squared minus 2 plus 5 equals 5 times 2 minus 1 is 1, which is just 1 squared, plus b times 2 times 2 minus 1, which is 1, plus 7 times 2. All right, 2 squared is 4, 4 times 3 is 12. Kind of do this a little bit less steps. 12 minus 2 is 10, 10 plus 5 is 15. Equals 5 times 1 squared. 1 squared is 1 times 5 plus 2b plus 14. If I subtract, if I combine my like terms here, sorry, 15 equals 19 plus 2b. If I subtract 19 from both sides, I get negative 14 equals 2b, or excuse me, if I subtract 19 from both sides, I get negative 4 equals 2b. And if I divide both sides by 2, I get that b equals negative 2. So we're going to go all the way back up here, bring it down, and we are going to substitute in our a, b, and c. So we are going to have that same thing on the left, 3x squared minus x plus 5 over x times x minus 1 squared equals, instead of a, we are going to put 5, so we're going to have 5 over x. Instead of b, we are going to put negative 2, so we're going to have negative 2 over x minus 1 plus, instead of c, we are going to put 7 over x minus 1 squared. Keeping in mind, these were the 3 factors we started out with at the beginning when we broke that apart. So there's our final decomposition into partial fractions. Lots of steps, lots of things to keep track of, so be very, very careful when you're doing this.